is your favorite for today? Take a seat. Alright, today we're going to be working on continuity and discontinuity, removable and non-removable. We'll start off with the problem here. Alright, before we start, can someone tell me what you think should we start off with?
Do you factor the denominator?
Yes, correct. So first we have to factor it out. Do you guys know what it factors out to?
X minus 6 minus 4.
Correct. Alright, do you guys have an idea of what to do next?
Do you cross out like terms?
Alright, we will cross out the like terms. Before that, we have to have the x's equal to 0. Alright, and what do you guys come out with?
6 and negative 6.
Alright, after that we cross it off. When you are able to cross off something off because they have the same like terms, that means that it's removable. So you could take it out of the equation. So this equation will then equal to, now this is not removable because there's nothing else that we could remove. This was our last point. So you cannot, x cannot equal to negative 6 or 6. Because if you equal to negative 6 or 6, it will, if we plug this back in, it will be 0. And that would just cause an error. So it would be discontinuous because you weren't able to equal out everything to the equation. Alright, now we're gonna do removal and non-removable with the graph. Right here I have a quadratic, and how we have done in previous lessons, limit. We're gonna solve limit x equals 0. So this is the point that we are trying to see if it's continuous or not. We're gonna start off to find limit, just in case you guys forgot. We have to see if limit x to the limit of 0 is negative equals to limit to x to the positive 0. Alright, do any of you guys want to come up and do x to the power x to the 0 to the negative?
So since the limit x to 0 negative is on the left side, it would be negative 1. It would be 1.
Alright, that's correct. Alright, Paula, would you like to come? Alright, that's correct. So now, do you guys think this is continuous or not continuous?
Continuous.
Alright, why is it continuous?
Because they match.
Correct. These two numbers need to equal to each other. If not, it will not match. The graph would be very different and they wouldn't be ending up on the same point. Alright, let's try a different question. Alright, so this is gonna be the second graph with graphing. As you can see, it's very different from the last graph. Before I teach you guys on how to do this, do you guys have an idea of how you guys would come across this?
No.
Alright, so you see how it's the same concept, it's just that these lines are broken up. They're not together as like the quadratic from the previous question. So that causes it to be a little bit more difficult. You will first start off doing the same concepts, going from the left to the right and from the right to the left. So you would go here and you would come up. And then you get this point. And after that you'll do the right, the same thing. But as you can see, they're very different. Do you guys know what that would be? And why that would be?
Because the y-axis, like, they don't equal each other.
Okay, we have to prove that though. Would you like to come up and do the first part?
Yeah. So since it's the limit of x to 1, a negative, it would be starting from the left side to the right.
Mm-hmm.
And as we see from the left side to the right, on the x-axis of 1, it's on 2 for the y value. So the y-axis would be 2.
Alright. Paula, would you like to come up for the second part?
So it'll be 1 because coming from the right, it goes to 1.
Correct. Alright. You guys did a great job.
Thank you.
Like Illumina said previously, it would be non-continuous because these don't add up and these two don't add up either. So that's why it would be